Is my screen visible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So we have completed first module of diode.
Yes, sir.
Then we proceed for second module, transistor. So today and tomorrow,
Transistor.
we'll do, and I think today is the meeting of AC. So here it will be finalized what is the syllabus. So tomorrow I'll tell what is the syllabus for mid-sem, and Wednesday means tomorrow we'll take one weekly test from diode equation to last class up to clamper, and next week one class test will take before mid-sem, one class test 5 mark. That may be Monday or Tuesday, next Tuesday will take, because after Wednesday maybe Thursday, Friday holiday, after that exam. So next Tuesday you prepare for class test and tomorrow for weekly test.
So tomorrow's timing, sir? Sir, because we have physics quiz tomorrow.
Class time, na? Class time में
Okay.
5 मिनट 10 मिनट.
So that will be a quiz.
Quiz. So we'll start transistor. So in this transistor module, we'll discuss the basic structure of transistor and what are the different type of current are flowing in transistor, current equation, different configurations, input output characteristics, load line, biasing, all these things we'll discuss in transistor. So basically transistor means it is a electronic component consist of three type of material like PNP or NPN. Like already we have discussed PN junction diode. So that means we have taken one P-type material and one N-type material. Okay, then we are getting a junction here. So this is called as PN junction diode. Now transistor means we have to take another material here. Suppose this is P, in between that N, then another P. So N is sandwiched between two P-type material. Similarly also you can take for NPN. So if I will take NPN, then this will be N, this will be P, this will be N. So here three terminals will take this side and here. Okay, three terminal we have to take out. So diode is a two terminal device, transistor is a three terminal device. One terminal is called as emitter, base and collector. E means emitter, B means base, C means collector. So this device first demonstrated in December 23rd, 1947 at Bell Laboratory. Three scientists, Stockley, Bardeen and Breton, three scientists, they have invented this one accidentally. Means they are doing some other work and accidentally they have found that whatever signal is transferred through this junction, they are amplified. So the first time they have demonstrated that one. And here we'll get two junction. This is one junction, this is second junction. So first junction is called as emitter base junction. Between emitter and base you get this junction. So this is emitter base junction. So I can write here EB junction. Second one is collector and base. So this is CB junction. Okay. So like diode we have one junction. This is transistor will get two junction. One is called emitter base junction, another one is collector base junction. Now generally this is called as BJT, that means bipolar. B stand for bipolar, J stand for junction, T stand for transistor. So this PNP, NPN transistor are called as BJT, bipolar junction transistor, right? The structure is shown here, NPN transistor, PNP transistor. So these are the structural thing, And if I go for symbol, like diode having the symbol like this, so this is your P, this is your N, this is your anode, this is your cathode. Similarly, transistor symbol, if you consider, you get first you have to make one circle, vertical line to inclined line which are not touching each other, then in between that another line. Okay, then you straight line like this. So this arrow mark you have to put it here. So this is the arrow mark. So arrow mark is outgoing. Okay, outgoing, or I can say it is not pointing in. Okay, so I can take this is NPN transistor. Not pointing means arrow mark is outgoing means it is NPN. Arrow mark is pointing in or incoming means that is PNP. And you remember this thumb rule, the arrow mark terminal is always emitter. Opposite to that, that is collector, the rest one is base. Similarly, if I want to draw PNP transistor, first we will take circle and vertical line to inclined line. So all are extended. Here arrow mark is incoming, right? So this is PNP transistor. So this is your emitter, this is collector, this is your base. Understood? How to draw the symbol?
Yes, sir.
So we have seen the structure, type, NPN, PNP, who has developed, when they have developed that one, and basically this is one layer sandwiched between two layer. Means if I take NPN, P layer is sandwiched between two N-type material. If I take PNP, then N-type is sandwiched between two P-type material. So that is shown here. Next, we'll see some important point regarding this transistor. Very important. You may get different short questions from here. First of all, we'll see why it is called as bipolar junction transistor. Okay, so bipolar means that means you don't understand that pole means something like north pole, south pole, like that. Bi means two, polar means type of charge carrier. Okay, in transistor you will get two type of current. One is due to majority carrier, one is due to minority carrier, or I can say the electron and hole both are responsible for current conduction in transistor. So two type of charge carrier contributing the current in transistor, that's why it is called as bipolar junction transistor. Okay, so this is a short question you'll get. And this transistor is three terminal device labeled as emitter, stands for E, B stands for base, C stands for collector. Fabrication time, generally the emitter is heavily doped. Means the doping is, suppose I'll take this is your emitter, this is your base, this is your collector. Suppose I will take or try to construct this one, then here doping is high. Doping is high, base is very lightly doped, and collector is very lightly doped. So what is the reason? I'll come in a moment. For the timing, you just remember emitter is heavily doped, base is lightly doped, collector is very lightly doped. And the total ratio, width ratio is 150:1. That means if here to here 150 inch, then this ratio is only one time of this one. So you can think how much thin is the base.
उसका चालू हो जाता है। आप लोग का मेरे को शांति से कभी रहने देंगे आप?
Samriddhi, your mic is on.
Who is talking? Okay. So emitter to collector, if you consider 150 inch, then base layer is only 1 inch. That means you can imagine how much thin is the base. Okay, it is 150:1 ratio divided. Though it is very thin, its effect is immense, because if you not take this base region, this is P, this is P, this is only a P-type semiconductor. But if I add this thin layer, then only it will become transistor. And what is the purpose of transistor? Amplification. Okay, main purpose of transistor is amplification. Whatever signal you are giving, that will be amplified at the output. Suppose I am giving 1 volt signal having 50 hertz frequency at the input, and I will take one combination of amplifier using transistor, then I may get more than 1 volt, maybe 2 volt, 3 volt, 5 volt, whatever the depend upon the design, the gain of amplifier, we may get high amplitude. Okay. The middle layer is lightly doped, and this doping ratio is 10:1. Suppose I'm taking here doping is emitter very high and collector is low and base is very light, so doping is 10:1. Means if it is doped with 10 to the power 5 dopant, here it will be 10 to the power 4. 10:1 ratio it will be doped. And BJT is current controlled device. You remember all these points are short questions. BJT is current controlled device and depend on both majority and minority carriers, hence bipolar name is given. Okay, as I already told you, two type of carrier, electron and hole, one is majority, one is minority, both are contributing the current flow, so that's why it is called as bipolar junction transistor. Bipolar junction transistor construction consists of two PN junction producing three connecting terminal, with each terminal being given name as identity to 2. That means as we have seen here, this transistor having two junction, PN junction and NP junction. If I take it here like this, this is P, this is N, this is P. So if I consider this junction, so this is one type of PN junction, yes or no?
Yes, sir.
Another PN junction is this one.
Yes, sir.
So actually it is two junction connected back to back. If I represent the same thing here, this is one PN junction. So this is P, this is N. Then right side like this is P, this is N. So two diode connected back to back. That means I'm not saying that if I connect two diode then it will act as transistor. Conceptually, two diodes can be connected back to back. So my point is that if you understand the diode operation clearly, then you can easily understand the transistor operation. Okay. So what are the points we have till now considered? Transistor 3-terminal device, emitter base collector. Emitter is heavily doped and the base is very thin, 150:1 ratio. Doping ratio is 10:1. It is called as bipolar junction transistor or BJT because two type of current. Current is due to two type of carriers. Okay, and it has two junctions: emitter base junction and collector base junction. Now, what are the application? So this PN and I have already explained you. So it is used in amplifier and oscillator circuits. It can also use as switches in digital circuit. So amplifier, oscillator, switch, we can use this transistor, but mostly we'll use as amplifier. Okay, you know, any electronics device now you are using, that is using this amplifier or amplification is required. Even when I'm talking here, you are at a distance, listen to my voice. So unless until my voice will be amplified or transmitted to larger distance, it is not possible. Okay, so amplification is mandatory whatever you take, even mobile phone, any electronic gadget or satellite communication, whatever the thing will take, amplification is must. So you know,
Sir,
yes.
sir, in the last part you explained that in PNP we can use two types of diodes. Sir, is it practically possible to use two diodes instead of
I
a
already
transistor?
told you that. I think you have not listened carefully.
Yes, sir. Could you
What
repeat,
I
sir?
told you. This is like a concept. If I take two diode, it will not work as diode transistor. Okay. Why I have explained this one? Because if you understand the diode concept, then you can easily understand the transistor concept. But if you take two diode and connect it like this, then it will not work as transistor. I told.
Okay, sir. Okay, sir.
I want to show you only the how it is related to diode chapter. Okay, two diodes like this. So if you understand the diode chapter, then you can easily understand the transistor. But if you go for that, then it is not practically possible. Okay. So amplification, oscillator, switch. So all these things we use this transistor. Computer, satellite, communication system, all these things are using amplification. Without that, this is not possible. So transistor's ability to change between these two states enable as switch. So amplification, switching, right? You have seen the logic gates. Logic gates, AND gate, OR gate, NAND gate, NOT gate you are using. You have studied, I think. So inside these logic gates, the transistors are there. So you can use transistor, register logic, diode, transistor logic to make these logic gates. Okay, whatever the gates you have seen, like OR gate means 0 0 0. For all other cases, it will give 1. So inside that, there is the transistors we use. So in the lab also, you'll see. Your online means you can go for this Tinker card. There you can see different logic gates. So IC numbers are there. So using that, you can go for different logic gates. So inside that IC, because IC is like this. Okay. So inside this, some components are integrated. So inside that, this transistor, resistor, diodes are connected to make this logic circuit fruitful. Okay. So it is current controlled device, I already told you. Now let us go for some other concept. See, this one we have discussed, this one we have discussed. So you can see this diode is connected back to back conceptually, not practically. Okay, because we have two junctions. Now if I represent the same thing in terms of symbol, then below it is represented. So let us see here how I'll represent. First I have shown this is my transistor. So P, N, P. This is emitter. This is base. This is collector. Now when I draw a symbol like this, I have told you, make this one. Then this is PNP means it will be pointing in arrow mark which is given, that is emitter, this is collector, this is base. Now what are the other things it is written? Let us see here. The arrow mark suggesting current is incoming. Okay, so the terminal emitter provides the emitter current, i.e. current due to emitter or current flowing through the emitter terminal is represented as IE, and arrow mark is incoming means that is IE also incoming. Okay. Now the current which is entering through emitter, that should go from the base and collector. So current from base, that is IB, current from collector, that is IC. Understood? Three terminal current: emitter current, base current, collector current. The terminal which we are taking corresponding to that, the currents are named. Any doubt? Any doubt? Now we will understand the terminal voltages. So you see here, this is between collector and emitter. So I can name it as voltage between collector emitter as VCE, collector emitter voltage. Voltage between base and emitter, VBE, base emitter voltage. Collector between voltage between base and collector, you can write collector base voltage or VCB. Okay, plus minus terminal will be connected when we go for circuit. I'll give you the plus minus connection, because here only the naming and terminology I am discussing, so we will not go for plus minus. Okay, so if you look at this figure and this figure, the terminologies are same. Only difference is that the plus minus symbol is given and the transistor is oriented. So this one, emitter base collector, the base is below side, that's why it is connected below here, and emitter and collector this side. So this configuration we'll name it little bit later. First you understand the terminology, then we'll go for this, why I have inclined the transistor vertically and horizontally. I'll explain. Any doubt from this part? From the starting, what we have discussed, started with transistor invention, then type of transistor, why it is called as BJT, then the terminal names, after that symbol, then the construction diagram, sizing, doping, and conceptually how it is related to PN junction diode, then what is the application. Okay, and after that the summary here, the practical or the structural view, conceptual view, and symbol with current and voltage nomenclature. Any doubt from this part? Has any doubt from this part?
No, sir.
So lot of short questions will come from this part, whatever we have discussed, like one or two example I'll give. Justify the name BJT. Okay, so what you will write? BJT is bipolar junction transistor. Here two type of current in transistor due to two type of charge carrier, that's why it is called as bipolar junction transistor. Then okay, then who invented transistor, then draw the symbol of transistor, then what are the different type of transistor, p type, PNP or NPN type, like these questions will get. And from this part, what are the application of transistor, also will get short question. This part, doping and sizing ratio, I'll come to this part. Okay, now see. Okay, listen very carefully. This is a long question, and within that I'll explain about the concept of why the doping, sizing ratio, all those things I'll explain. Okay, very, very important. So if you consider a PNP transistor, I am taking PNP transistor because the direction of carrier movement and current direction will be same. So that's why I have explained here. You can take also NPN transistor. If you take that one, the electron movement direction and current direction will be opposite. So you have to make the direction opposite to movement of electron. So for easy understanding, I have taken here PNP transistor. Okay, but practically NPN transistor is used because mobility of electron is high, so we'll get more current. So comparatively, NPN transistor we are using in lab, but understanding is easy in the PNP transistor. That's why I'm taking here. Okay. Now, first of all, if I take a transistor, PNP transistor, emitter, base, collector. So emitter terminal is arrow marked. So here just now what I have given you, look at here, emitter current is incoming, yes or no? Arrow is into the device. So if I represent the same thing here, arrow is like this, yes or no? हाँ कि नहीं?
Yes, sir.
Next, collector current is outgoing, base current is IB, outgoing. Now, emitter terminal, what is the purpose? I want to transfer my carriers from emitter to collector. That's why the name is given like that. Emitter means it will emit the charge carrier, collector means it will collect the charge carrier. That's why the name is like that, emitter and collector. So emitter will emit the charge carrier. What type of charge carrier it will emit? Whatever the charge is present. Here in this case, P is the emitter or P type material is in emitter. That means holes and electrons it will emit. If I take NPN transistor, then it will be emit electron and hole. Electron as majority carrier, hole as minority carrier. So whatever the carrier present, it has to emit through the emitter. Now, if emitter will emit the charge carriers, then if I dope more, then I'll get more charge, because doping increases means the number of majority carrier increases in the p-type material. Yes or no? Why we are doping? Why the materials are doping? Answer. Why semiconductor materials are doped, or what is the use of doping?
So to increase the conductivity.
To increase the conductivity by increasing the carrier concentration.
Yes, sir.
So here emitter is heavily doped because I want to emit the charge carriers from emitter. If I less dope, then less carrier will emit. If I dope more, then more carrier will be present here, so that will be emitted more. So that's why emitter is heavily doped to increase the carrier concentration in the emitter, which will be transmitted to the other part of the device. Is it clear why doping of emitter is high or heavy doping? Because it has to emit the charge carrier. So that's why we need more carrier. So doping will be high. Now, collector is lightly doped and base is also lightly doped. So what is my aim? My aim is to transfer the carrier from emitter to collector. Okay, emitter will emit the charge carrier, that carrier should reach at the collector. Okay, so whatever, if I get more number of carrier here, then more number of carrier will transfer from emitter. So this is heavily doping, that's why I am making more dots. Here less dots, here also less dots. Why? Because here from emitter, I want to transfer the carriers to collector. In between that, base is coming. Now, base is very lightly doped. Why? Because hole are majority carrier in the emitter. When hole is moving to base, then I'll find electrons as majority carrier. And if I'll dope more doping as base, then what will happen? I'll find more electrons in the base region. So more electrons are in base region and holes are coming from emitter. What will happen? अरे इलेक्ट्रॉन बेस में ज्यादा होगा, होल एमिटर से आ रहा है, तो क्या होगा?
सर वो स्टेबलाइज हो जाएगा.
हाँ,
स्टेबलाइज हो जाएगा
स्टेबलाइज
मतलब होल्स इलेक्ट्रॉन पकड़ के वो कैंसिल कर देंगे ना.
हाँ, रिकॉम्बिनेशन, दैट इज रिकॉम्बिनेशन ना.
यस सर.
रिकॉम्बिनेशन हो जाएगा, रिकम्बाइन होगा तो फिर तुम्हारा ये न्यूट्रल हो जाएगा. न्यूट्रल होने से मुझे यहाँ पे कलेक्टर पे और कलेक्ट कर पाऊंगा?
नो सर.
So my aim to collect the carriers which is emitted from the emitter to reach at the collector. Okay. So if I dope more in the base region, so more number of recombination will happen. Whatever I am expecting to reach at the collector, that will not happen. So doping is very less in the base region. Okay. So that suppose 100 holes are coming from the emitter, and I'll find 2 or 3 electrons due to the very lightly doped. So maybe 2-3 holes will recombine in the base region. So 99 or 97 holes will reach at the collector. Out of 100 I am sending here, 97 holes will reach at the collector. Only 3 will combine here in the base region. That's why base is lightly doped. As well as the ratio. Here what I have told you, 150:1. That means this is only 1 inch if the entire thing is 150 inch. Here I have shown equal distance because I have to show here the current component. That's why intentionally I have given like this. But actually if you see the practical diagram, it is very thin. So if this is your emitter, then like this. So emitter width this much, collector width this much, base width this much. So now tell me whose width is very small, thin?
The base.
Base. And wider one? Collector.
Collector and emitter.
Collector and emitter, no. Compared to emitter, collector will be wider. Okay. Why I'll tell. So one by one I am explaining. First doping is complete. So base region is over. Now come to collector region. Collector is also very lightly doped because whatever carriers I am sending from the emitter, it should collect at the collector. If already more number of electrons, holes will be present here by heavy doping, then what will happen? Hole will come and it will collide with another hole. So lot of heat will develop here. Okay, so that heat can damage my transistor. So to avoid that, the doping in the collector is also very less. And the
Sir, could you explain again, sir?
This one?
Yes, sir. Collector part, sir.
Collector part. See, holes are coming from here to here. So intentionally, the thickness of base is very narrow and doping is less. So this hole, suppose I'm sending 5 holes, it is coming to the collector. If already in the collector I'll heavily dope, then this hole will come to collector and collide with the holes which are present here.
Yes, sir.
Now collision means what? Energy transfer will happen.
Yes, sir.
When 2 holes will collide, then what will happen? The energy will transfer. So this energy or this collision will generate more heat. Energy means what? So energy transfer means, like suppose you are using these mobile phones. When you are talking, what happens? The current flow in terms of signal, and it is getting heated. जितना ज़्यादा बात करते हो, जितना मूवी देखते हो ज़्यादा टाइम के लिए, क्या होता है, हीट डेवलपमेंट होता है. दैट मीन्स एनर्जी इज रिलीज, वट एवर पावर we are sending, that should consumed by the device, and it is radiating with the heat, because energy cannot create nor be destroyed. It is only transferring from one form to other form. So in the form of heat, it is radiating. So here also, if I heavily dope this one, then it will generate more heat. So that heat can damage my transistor. So that's why two things are taken here, or done. One thing is doping is less to minimize the concentration here. Another thing is the width is also wider. If you compare the emitter, base and collector width is more, so that heat per unit area is increasing, means heat per unit area will decrease. So the power dissipation capacity will be little bit stabilized. Okay, so two things are done here. So the main objective is that to transfer the holes from emitter to collector. To maintain that one, emitter is heavily doped, and to minimize the recombination in the base region, it is thin as well as lightly doped, and to maintain lower heat or energy, the collector is heavily lightly doped as well as wider area. So this is the constructional view, and when the transistor is made up of, these things should be taken care. Understood?
Yes, sir.
So again, come to the points what we have discussed here. I have explained here why it is lightly doped, heavily doped, why the ratio is 150:1 in the base region, doping, and here another point is not written, you can write here, collector is wider compared to emitter to reduce the heat in the circuit or heat in the component. Clear? Now we'll see, once we understand the basic things, then we'll go for the current component. So what are the current components are present in the diode or transistor? We'll see. Same picture, I'm doing it in bigger way. You just see here. I'll explain. This is your emitter, base, collector, P and P. So I have taken here collector wider and emitter little bit less wider than collector, and base is very small. Doping is according to the discussion. Now until unless we'll connect junction, because this is the emitter base junction J E B, and this is collector base junction, that is JCB. So until unless I'll bias that diode, current will not flow. So now tell me, emitter side p-type material is there, or emitter is constituted of p-type material. What are the majority carrier and what are the minority carrier I find? P-type material. In emitter, what is majority and what is minority carrier?
Whole majority.
Whole majority and minority. Now I want to push these holes towards the collector. Okay, because just now we have explained the carrier should emit from the emitter and receive at the or collect at the collector. So holes, मुझे होल्स को एमिटर से कलेक्टर पहुंचना है, तो कौन से टाइप का वोल्टेज यहाँ पे एमिटर में कनेक्ट करूंगा? one hole is here. I want to transfer these holes from here to here. Then automatically it will not move, because if I not bias it, then random motion will happen and net movement is 0. So I have to bias it. So यहाँ पे emitter में कौन सा voltage लगाने से वो right side को push होगा. तो इतना टाइम क्या लग रहा है, तुम समझ में आ रहा है कि नहीं? होल पॉजिटिव चार्ज ना नेगेटिव चार्ज है,
तो
तो
पॉजिटिव
मुझे करना है राइट साइड, तो कौन सा पोटेंशियल यहाँ पे लगाऊंगा, प्लस ना माइनस?
प्लस.
तो इतना टाइम क्यों ले रहे हो? So if I connect positive potential here, then I can pull the holes towards the right side. So that's why I'll connect here positive voltage with respect to base. Okay. Similarly, I want to receive these holes here. So this is pushing the positive potential what I have connected to emitter side, that will push the holes. But here across collector, I'll connect one negative potential so that it will also attract. Okay, negative potential, it will attract. So I'll name this one. Let us take this is V EB, this is VCB. Now you consider the junction here. First PN junction, emitter base junction. This junction is forward bias or reverse bias? Tell me. Are you able to visualize this junction? This is a PN junction. This is forward biased. Now opposite junction, collector base junction. Reverse bias. So this is the thumb rule. You remember, whenever I want to operate my transistor for amplification purpose, always the base emitter junction should be forward biased and collector base junction should be reverse biased, because I want to transfer the carrier from emitter to collector. Okay. Once I do that one, then we'll go for this carrier movement. Now, in this area of emitter, I'll find holes as majority and electrons are minority carrier. Now holes will transfer from emitter to collector. Okay, the movement of hole is like this. Yes or no?
Yes, sir.
Now if hole are moving from left to right, what is the direction of current?
Right to left.
Hole, B is hole, na? Hole movement, current movement opposite to each other.
No, sir.
Left to right. So the area in which emitter is present, that means from here to here, I am considering this is emitter current due to hole. Okay, due to hole, and I have represented here IEP. And base is lightly doped, very thin. Suppose I am sending 100 holes here. Let us take 2 hole is combining in the base region and 98 holes are reaching at the collector terminal. So due to that, I'll get a current across collector which is represented as collector current due to holes. Why 2 holes are recombined in the end region or base region? Because some combination will be there, because we have not taken intrinsic this n-type material we have taken, so electrons are majority carrier, some carrier will be there, so we can decrease that one, but we cannot nullify that. Okay, so if I am sending 100 holes, 2 holes are recombined in the base region and 98 holes are reaching at the collector side. Is this concept clear? अरे हाँ कि नहीं, जल्दी बोलो.
Yes, sir.
Yes, sir.
Now emitter side, you look at emitter side, holes यहाँ से बेस होके कलेक्टर में पहुंच गया. ठीक है. Now what about because this PN junction, this is PN junction. So this PN junction is forward biased, means majority carrier I have considered. Take this one as my junction. This is P, this is N. So now go back to the PN junction diode characteristic operation. When the diode is forward biased, what happens? The depletion region decreases. Majority current will flow, majority carrier will flow from one side to other side. So P side majority is holes. So holes are moving from emitter to base. That we have denoted here. Similarly, the electrons in the N side will be majority. So these electrons will move to P side also. Yes or no? Electrons are majority here. Just now we have considered holes as majority carrier, and this junction is forward biased. So holes are moving from here to here, because here doping is less and the width is very small, and we have applied negative voltage here. So holes are attracted to the collector side. One part is over. Similarly, here electrons are also majority carrier. So these electrons will move to P side or not, means emitter side. If I take a PN junction here, PN, I'll forward bias it. What will happen? The depletion region, initially some depletion region, then depletion region will erase. Then what will happen? The holes present here as majority carrier and electrons are present here as majority carrier. Similarly, electrons in P side magnetic carrier, and here holes as magnetic carrier. What we have studied? When we increase the forward bias after this depletion region erase or threshold voltage, then holes will move from here to here and electrons will move from here to here. Yes or no?
Yes, sir.
So same concept will apply here. So when it is forward biased, holes are moving from emitter to base, base to collector. Similarly, electrons will also move from base to emitter, this direction. So electron is moving this direction. So what is the current direction? Emitter is electron is moving from base to emitter. So what is the direction of current?
Sir, emitter to base.
Emitter to base. So I have represented here this one as I'm representing here as IE due to electron. Okay, so emitter base junction things are over. So overall, whatever current I am taking here, IE, that is due to electron and hole. So I can write IE equals to IE due to hole plus IE due to electron, which are leaving the emitter. Is this part complete or any doubt? First, you consider emitter base junction like PN junction diode. We have forward biased the diode, so holes will move, majority carrier will move. That means holes will move from emitter to base. Similarly, electrons are moving from base to emitter. So both the direction current is emitter to base. That's what we have discussed. Is this clear? Because if you not understand this one, this is very difficult. Very simple way I am explaining. Try to understand. If you have doubt, ask me now. Now, the electron is moving from here to here. Let us take electron is moving like this. So it has covered some portion in the base region and some portion is the emitter region. So while covering the distance in the base region, it will have some current while covering some distance in the emitter region, that will also have some current. So I'm just giving the different name in the base region and different name in the emitter region. So I'm giving here the name as IB current while it is moving in the base region. Okay, so I'm giving the name as IB1. Okay, now come to the previous case. When holes are moving, as I told you, 100 holes are moving from emitter, then 2 holes are reaching at the base, recombine, and 98 holes are reaching at the collector side. Now these two okay. Now the 2 holes which are combined here in the base region, that will constitute some current, and that current, let us take IB2. So base current, I am getting 2 component till now. One is the electrons which are moving from base to emitter, that will constitute one component, and whenever the holes are moving from emitter to collector through base, that component will give you some current. Is it clear? Base current, emitter current, 2 component I have explained, emitter current, base current. Any doubt, you ask me.
Sir, can you explain that IB2 part?
IB2 part. But I told you 100 holes are coming from here and reaching here 98. So 2 holes are combined in the base region. Combine मतलब क्या है? Suppose this is the base region, electrons are moving, and here the hole is moving here, and this hole is meeting the electron here. So it has traveled this much of distance or not?
Yes, sir.
So during that travel, it will give you some current. So that current is IB2.
Yes, got it.
Now, emitter base junction is over. Now we'll focus on collector base junction. Collector base junction is forward bias or reverse bias? Reverse bias. So let us see only reverse bias condition. Then I'll club it here. Like I have given you forward bias condition. Is there any class now? Just 2 minutes.
Yes, sir.
Just 57. No? Just 2-3 minutes give, because it will left behind means again I have to repeat it. So let us take this is PN and I'll reverse bias this one. So reverse bias, what we have discussed in the PN junction, the depletion region will be wider, yes or no? And while it is wider, the majority current, like this will not flow, majority current will not flow, but minority current which is present here, they can easily transfer from here to here, here to here, because in P side we'll get negative ion and N side will get positive ion. In that we'll get electric field plus minus. So that's why the electrons can easily, or magnetic carrier can easily flow from one side to other side. What we have discussed in PN junction diode, do you remember that? In reverse bias, magnetic current can flow, but majority current cannot flow. So that same concept is applied here. So if you take this PN junction, right? So what are the magnetic carrier in collector? Electrons. So electrons can easily flow to base region, and holes in the base side can easily flow to collector side. Understood? Magnetic carrier as magnetic carrier. So due to that, we'll get some current. So electron is moving from collector to base. So what is the direction of current?
Base to collector.
Base to collector. So you see here, this one is your IC O due to electron. ICO, I have written here ICO due to electron. Okay. Similarly, hole is moving from base to collector means the direction is base to collector. So the upper one is ICOP is written. Okay, you see here ICOP, ICON. So both the current is let me show here. Okay, so both the current is flowing in the same direction. So ICO due to electron, ICO due to hole, both combiningly I can say ICO. ICO means this is the leakage current because this is the minority current. So IC is equals to this current plus this current. So IC, total IC equals to ICO due to P or holes which are coming from emitter to collector, and another current component which is due to the minority current in the collector base junction. Is it clear? Now what
Yes,
about
sir.
base current IB? See, IB is what is the incoming current, what is the outgoing current? Can you tell me? IB1 incoming into the base, IB2 which is also incoming, IB3 both the components what I have shown here in the base region I can take, that is IB3 which is outgoing. Okay, so this is minus IB3. So total component which is present in the base, that is IB1 plus IB2 minus IB3. These two green lines, that is IB3. Okay, so both are incoming IB1, IB2, and IB3 is outgoing current. So total base current is this much. So I can write here in the base, that is IB. So IE, IC, IB, these are the three components we have discussed. And if I take entire thing as KCL, yes.
So we have physics class at 1.
I already told you, na, you hold for 1-2 minutes.
Yes.
So total current, emitter current, left side whatever giving, that is equals to IC plus IB. So this is the base equation for any transistor. Emitter current is equals to collector current plus base current. And individually, emitter current is due to this plus this. IC is this plus ICO, and base current is this current plus this current minus this current. Okay, so this is your IB component, and this is the base equation, and IC is equals to alpha IE. This will be discussed in the next class. Why this alpha is taken, I'll explain in the next class. Okay, so you go for this because this is very critical. You need to identify what are the components in the transistor, and this will come as long question. Explain the current components in transistor for NPN or PNP transistor. Same way you can go for NPN transistor also. Okay, so that's it. Just wait for 2-3 seconds. I'll take the attendance. Then you can go. Because if I skip from the middle, again I have to start from figure all these things. That's why. Okay, attendance is taken. You can now leave. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.